Okay, let's continue. What the heck? That was weird. So one more C matrix. I'll have to look into what this escaped code is. It's like for auto wrapping. I don't know how it's supposed to be used. I'll look at that later. So let's continue with this glyph cache. I did look up some stuff in my break here, so I should have I have roughly a better idea of what we should be doing here. So first, I want to rename this to initialize font cache. Initialize glyph cache. And it's going to take a glyph, what's it called? Glyph cache. It's going to take a glyph cache. And it's going to do a few things here. So to make this easier on ourselves, we'll probably still just store the glyph cache len. Even though it's like a pound define. Anyways, so what we're going to do in here is we are going to so we want to, when we just make this or reinitialize it, we basically want to loop through all the elements. And what we want to do is we want to say basically we want to initialize here. Sorry, I'm kind of referring to like ref terms, which is Casey Muratori's thing. It never worked, but I'm not a fan of like how he structured it, but I can at least get the rough idea of what he did, because he does know like a thing or two. So what we're gonna do is we are gonna say so collision count. Let's not use that. We're still gonna have this like next with hash. The next entry with the same hash. And in here we're gonna grab an entry. We're gonna grab a cached glyph pointer. And then we're going to if this is stupid, but we're not calling this all the time, so I don't really care. If I plus 1 is less than GC to glyph cache len, like I can clean this up after, but it's also not a big deal. CG to next with same hash, next with hash. Let's call it next with same hash, so it's very clear what we're doing here. is going to equal just the next index. Else CG to next with hash is going to be 0. The last one will have a 0. And then we'll do, we don't need that. Next and previous in the LRU chain. So yeah, we're gonna do this. So we're gonna do CG to previous equals 0, CG to next equals 0. We'll do that, and then we're gonna say CG to code point equals 0. It's invalid. So we're gonna do this. And we're also gonna do GC to MRU index 0. Least recently used index 0. We actually don't need these. So we're gonna use like the 0 input as a sentinel, because you shouldn't be giving a hash with 0. The only way you can get a hash with 0, pretty sure. But we'll see anyways. Let's just say we're gonna have a sentinel, and we don't need these for suffice that for now. Okay, so then what we're going to do is we're going to go into here, render glyph. We're going to make a new function that's going to be get glyph entry from hash. So get glyph entry. It's going to take the glyph cache, and it's going to get a 32 code point. Okay, and then what we're going to do, probably the index, because we need the index. And then what we're going to do is we're going to do so we're going to say in here, I mean I32, doesn't matter. So we're going to grab the hash, get glyph entry index, Code point. This weird thing that we're doing here, we're not gonna do. Yeah, we're not gonna do this thing here. We're gonna say, if IDEX else, we need to do a IDEX is going to equal pop free what's it called? Pop free glyph entry. So it's going to pop off the least recently one and give us back that index. Okay, we're going to do this. Then we're going to grab the index. We're going to grab that one. What are we doing here? Let's try this for now. Otherwise, this is going to be 0. So 0, 1's going to be Sentinel, but that's okay. So what we're going to do is close this thing for now. And we're going to go up here, and we're going to do... This is going to do the lookup. We'll cover that in a second. Cache glyph sentinel equals GC to glyphs. This is the 0. Like plus 0, but that's fine. Let's do plus 0. So it's clear what's going on here. And I think Sentinel is with an E. Okay, so if there's one with, if the Sentinel has a, so basically we're going to use this to determine if the, sorry. Yeah, sorry. So sorry, yeah, so we're going to use this to grab the last index. So we're going to do this. do a recycle cache. Then we're going to say sentinel to next with same hash. Which shouldn't be 0 at this point. So we assert that. Then we're going to say that the hash glyph is going to equal gc to glyphs if this was spelled right. Plus result. We want to say that the sentinel to next with same hash is going to equal CG next with same hash. So we're going to basically push this down the chain. And then we're going to set this hash glyph result is equal to 0. So this is the end of the chain. And then we are going to return the result for use. Okay. And this, don't know if we should be doing this here. We definitely don't have this index anymore, so that would be wrong. Okay, so then we need to do a few more things. We need to do the recycling routine. The only way we can do this is actually, I think it just has to be kind of slow. So we're going to grab this thing again, and then we're going to basically there needs to be a previous there needs to be a previous element. So then we're going to say yeah, we're going to grab this. Going to equal this. This is the last one that was used. So to grab a glyph, We're gonna grab the previous glyph as well. The first set, that's gonna be, these are both pointers. This should be a pointer. This should be last index. Okay, so now previous to next is going to equal 0. Sentinel to previous is going to equal this. Okay, and then we're going to do let me think here. So yeah, this is not what I mean to do. Right, so sorry, my bad. So we have to we want to go up one. Sorry, this is not what this is. This is for this code point. Yeah, we need to get this code point, and then we need to loop through all the things in the chain and remove the last one. So we need to just skip over everything up until we get to this last index. Unless this was the first one, so next index is going to equal, what's it called here? GC to glyphs, next index, next with same hash. Okay, and then what we're going to do is just like assert in here that we have like a 0. We don't have any zeros. We know this terminates at some point. Okay. Okay. So hold on. This is again where I'm like a little confused, but what's going on here? Okay, yeah. This doesn't even make sense. I don't know why this code is written like this. Casey, what are you doing, man? Weird. This code does not make any sense because we don't even need to do any of this stuff as far as I'm aware. What is even the point of this? Oh, I see. Right, sorry, this makes sense. Yeah, so sorry. Casey has this, his structure is like really strange. So, okay. So, next index dot next with same hash equals then CG to next with same hash is going to equal the sentinel. And then the sentinel next with same hash is going to be equal to the called here. Yeah, it's the last index. Okay. So then what we need to do is just clear out the last cell. So we're going to say that CG to size.w. Wait, let me just check this quickly. So yeah, what's in these hash glyph? Yeah, basically what we just want to do here is grab the actual glyph itself and set the size to 0. And the delta to 0. And then we're done recycling that. Okay, so let's see here. Now we just need to do this get glyph entry. So get glyph entry index. We're gonna do this, and we're gonna say oh, okay. I'm gonna static assert this in a second, but so hashed glyph go in here. result equals I to X break. Next with same hash. Okay, so this then we break out of this, we say if result we're gonna do previous and next. We're gonna grab both of those. Yeah, never mind. Okay, we can do that, and we're gonna do well, I'd like this to be outside of here, kind of. Otherwise we need to return 0 so that it can grab the other one. Oh no. Not yet, sorry. To do that. Then we're gonna say right, this is where this gets weird again. Yeah, we can't have this. This is like the wrong order for this to be occurring in. Really what we want to do is do this. And we don't want these to be calling those functions. So in this recycle function, we need to do something a little different here. Yeah, so this is a problem. So we need to be able to find the first entry that this glyph pointer came from. So like this code point leads to the first entry in the table. Yeah, actually what we can do is split this up. So we're going to do static U32 compute glyph hash. I'm going to break this out. We're going to do this. Compute glyph hash. Okay, so we do that. Then we're going to do okay, so we're going to do that. We're going to get this. Everything's looking good so far. Else we need to, we're not going to return a result here. Else, spelled correctly, we need to grab the IDEX is going to equal pop free thingy. Or really the result is going to equal pop, what's it called? Pop free glyph entry, GC. What did I do? I think it's just GC, right? Yeah, okay. So we're going to do this. And then we're going to say that CG is equal to this. Is going to be equal to not IDEX. What's the correct thing here? Rename this. And CG, take this. Right, we're moving this to the top of the thingy. That's what's going on here. Um, Let me just think here and make sure this is correct. Basically, what I want to do is ensure that the next time we just come and hash this thing, it lands in this exact slot. Um, so I'm thinking what I need to do is actually, um, I need to put some water on for some tea and go to the washroom for one. But what I need to do is Glyph Cache. Um, So if you have a second thing here that's just the hashes, then you can do this better. So you look up in this hash table, and that gives you the first index in glyphs to just search, and then you can go through and check the other indices. Yeah, we're gonna do that. I'm gonna grab that stuff out of here. Static assert is power of. I have a macro that does that. I don't know if I do. But I had a macro that did that. Maybe I don't. I might need to add such a macro. is power of 2. I don't know if you can have a number in a macro name like that. Is power of 2 a x a, I don't really care, is going to be evaluated to value a, sorry, a and a minus 1 be equal to 0. I think I'm using this somewhere. Yeah. Compute. Are we going to get a crash once this actually builds? So I'm gonna have to look over all of this again now. Once this builds. Yeah, this is wrong. Okay. Entry IDEX. Fix that. Make sure I don't something stupid there. Glyph Cache. Yeah, it won't build, so that's good. I just want to make sure that 137. Eventually this is going to return a result. Make sure these are all just okay, the one in VTGL we need to fix. Invalidate thingy. It should be initialize font. What's it called? Init initialize glyph cache. Okay, we will fix that first. Okay, and we'll just let those 3 continue to be broken for now. So I don't want this to crash on me right at the moment. So I will be right back. I'm gonna go to the washroom and put some water on quick. Okay, so go back through this and make sure everything is now looking like it makes sense. So first of all, we need to here we're going to need to do a mem clear on the hash table. And it's going to be 0, and it's going to be size of hash table times GC to glyph cache count. Do that. Just open our util here for a second. So glyph cache. That's fine. There's nothing really wrong here. Very weird. Oh, I see what Casey did here. That's smart. Okay, I'm gonna do that too, actually. That's really smart. Initialize glyph cache. So, so what we want to do actually is just, no, we want to do this. So we're going to do this, but what we're going to do is we're going to say, we're going to actually take this as a pointer in the font atlas. Do this. It's going to break everything once it builds, but that's okay. This is going to equal size of glyph cache plus glyph cache len times size of What's it called here? Size of cached glyph plus size of U32. Then what we're going to do is do this instead. This up here first. And we'll do this. We're going to do our little alloc here, which is going to be we're just going to do U8 pointer. We're going to do U8. But we want it to be like aligned properly. How can I do this so it's not, the alignment doesn't get screwed up? Let's grab my tea quickly. Oops. Okay, let's have a separate function called, or a separate macro rather, even, called alloc aligned. So alloc is already a macro, which calls, actually defined not in here. It's defined in here. So alloc is already a macro, which calls alloc. But we're going to do this differently. We're going to have this. We're also going to have a macro here called alloc aligned. Which is still going to take this arena and a type. It's going to do 1 and n. With a line of the type. Call it something different, just so it's more clear. Alloc explicit align. Glyph cache size. Glyph cache. That has the correct alignment. And then I'll have the correct size. Okay. This looks fine to me. So we've got that. Now, when we do this initialize, we actually have to do some... Actually, we don't have to do anything there. It's just here. We need to do a little bit of a tricky-do. even gonna call it that. Tricky do to it looks correct to me. Or sorry, that's not quite right. Plus Glyph Cache land. Yeah, that looks correct, I think. So, +1. I'm gonna have to check this in a second because this seems. This is some weird tricky do that Casey's doing here. I think this is correct. Okay. So probably the compiler is going to spit garbage at us for doing that. Right, we need to fix that. But other than that, I think that's fine. C, stupid C nonsense. Oops. Sorry, that's not correct. Sorry, I need to. This is completely wrong. So we need to do this. Then we need to we're not going to store it directly into there. We're going to make this better. Yeah, let me do this a little better here. So we've got this glyph cache length. We're gonna get a so why am I actually doing this? Like why does this table need to be in here? It doesn't. Glyph cache dot glyphs memory um glyph cache hash table. This is where the tricky do comes in. Let's go to this. T2FA glyph cache dot glyphs plus T2FA glyph cache dot glyph cache length. Okay. You know what? I just realized this was a stupid. The reason Casey was doing that is because his memory is not from one big block, but our arena is from a giant block. So what I had here before was totally okay. What I did was totally fine before. We don't need to do any of this weird cryptic nonsense. Good use of my time. It happens. Okay, so we're gonna keep this lined up. So font atlas. This is not a pointer. Should all be fine, to be honest, how it was before. Okay, so we got this. Close this. That can remain broken. So then what we do in initialize glyph, we memset this table to 0. And that, I think, is all we need to do for that part. Then for the get glyph entry index, we're going to compute our hash. We're going to get this hash slot out. The entry index is going to be equal to gc to hash table of hash slot. And we're going to say, well, entry index. Hash table of hash slot should be equal to this is wrong. It is going to be the so if result yeah, so sorry. So the next with free thing is going to be this. Then this is going to be this is going to be the result here, this entry index that we just got. Okay. Then after we're done this thing, we need to grab the sentinel index. We need to, well, that's a good idea, is to assert that the sentinel well, really it's just assert result is not 0. Then we're going to grab the Sentinel. We're going to mark the... Oh, what are we even doing with the Sentinel? Never mind. I don't think we need the... Oh, sorry, we do. We need to grab the next index from the Sentinel. So, okay. So this result to next is going to equal Sentinel to next. And the Sentinel to next is going to equal CG, the result index. So we're putting the result of this operation at the front of the list, meaning it's the most recently used item. Sorry, I think I did something stupid here. I mean, this is correct, but yeah, right. And then the CG to previous is going to equal 0. Okay, so this should be fine. Just make sure I'm not doing something completely ridiculous here. Yeah, sorry, we don't want to overwrite this just yet. I mean, we do, but also need to grab the sorry, CG to next, CG to glyphs to next to previous is going to equal the result. Sentinel to next. Let's make this a little bit more readable. Last next to previous should equal result. Okay. That's good. Let's go up to this pop free thing because I think I might have messed something up. It's possible. Maybe it's not. Who knows? This free thing I think is correct. So grab a Sentinel. if there's not a next thing with the same hash, we need to free some space. Then we grab this. It needs to be a result. Then we do this. Okay, this looks good to me. This recycle dealio. Just make sure this is looking good. Grab our sentinel. There should have been a previous element in that case. So we're going to grab it. Then we're going to say that the entry is that one. Previous entry was that. We're going to delete the previous next. So this looks correct. And then the sentinel to previous is going to be the this guy. And then we're going to get a hash slot index. So this is actually hash slot. And then we're going to do while gc to hash table of hash slot does not equal that. We're going to assert wait a minute, let me think about this. So we're going to, oops, didn't be like that. So we're going to grab the next index out of the hash table. And while that index does not equal the last index, which was Sentinel's previous element, we're going to walk along this table. We should save this hash thing. Oops. So then what we're going to do down here is we're going to say that this is actually what we want here. So we want to insert this into the hash slot. Okay, this looks good to me. So now we just need to fix the debug stuff, and this will probably, it's going to definitely crash. So I'm going to close this second, and we're going to use this one. So what's our bugs? So in this dump glyph cached file, I'm gonna if zero this for now. It's not gonna do anything, and then we'll fix it. We're gonna add a different dumper thing in a second. So, okay. This should build. How's it gonna crash? Yep. So what are we hitting there? Map failed. Yeah, because it needs to know what the thing is. I thought I called that function though already. Needs to know what the size of the glyphs are, cell size. It should not be 0 and 8. So, what did I do? Should call it initialize glyph cache. Only place that gets called is there. Because this needs to know what the cell size is. But update font textures should go through here. Okay, I think what I did is I forgot to finish writing the render glyph code. So, okay, right. Out index equals this equals that. What we need to do is, this is wrong. So index is going to be assumed to be valid. So we're going to say cg to glyph dot size dot w equals, if there's like a size, we're going to do this. Otherwise, we need to do this. And all of this is not needed. We're going to do this. This is wrong. And the rest of this, I think, is correct. Yeah, there we go. Okay, so cool. Uh, can get rid of that. That's not really necessary. All right, so now we should have a working least recently used cache. Now, how can we just confirm that it's working? That is the question. I mean, yeah, I don't know. Let's open this debug.c and we will write something here that's going to let us dump some information about the cache. And maybe we should add some information to the cache. Okay, well, first of all, we'll print this chain, and it should have it should terminate now, so don't really need this. We're gonna say glyph cache. I equals p to equals gc to glyphs 0 dot next. While we have I, this collision count isn't thing anymore. We'll have to do something else for that info. So let's just see if this gives us a chain. Yeah, I did mean that. Thank you. Okay, so now if we do an F3, hopefully we don't just do some stupid thing. So we didn't, we terminated that time, which is good. That's the first step to knowing that we're working. So we're gonna go through this loop. We get like a 1 to 23 to 18 to 13 to 24, blah blah blah. We just jump all over the place in that table. That looks good to me. Let's print like the glyphs along the chain as well, I guess. So we're gonna do this. Yeah, sorry, never mind. Is equal to GC to glyphs. What's that function return UTF-8 encode? It returns like a static buffer, 4-character buffer. Okay. That returns an S8, sorry. UTF-8 code. Code point. And we're gonna print we're gonna do an F right. F what's F right? Pointer size, number of items. Coded.data rather. One encoded.length. F. Okay, so should do the trick. So now if we go ahead and run this and open the thingy, what happened? It didn't rebuild. That would help. And I should make sure there's a new line here. Okay, now if we do this and we open the thing, oops. So we get a space to C to dot to G to UB blah 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 blah. That thing's in there. And then we should also print, let's print a count. Why is there like an extra new line there? Weird. Let's do this and we'll do the count. So that makes sense. We're not like anywhere near full, right? We're at 97, which seems reasonable enough to me. And it doesn't surprise me that space is like always at the top. It's always the last character that's getting printed. Does that make sense? Okay, and then there's one other thing I want to check actually. So this, we're gonna see if this breaks everything. I don't really know what's going on with this comment here, to be honest. So I feel like that shouldn't cause any issues. Like I don't know why well, we have to resize for it to be an issue. Oh, we can't resize anymore. How did I break that? Okay, let's just leave this here for now and figure out how I broke that. Right, yeah, we can't resize. Okay. Let's see how we broke that. So zoom, update font textures. Right, we didn't actually upload new Delios. No, we should have actually, right? If we initialize this, previous code point is 0. Just make sure all the sizes are 0 as well, just to be safe. Okay. So now we can resize that. That's what we want. All right, now was definitely the problem. Okay, and then what we wanted to do was go in here and check if this thing is needed. I think it is. I think that yeah, okay, that is needed. Because the check is checking for 0 width, and that is actually correct. It is 0 width for some reason. So, yeah. All right, cool. So let me just get up and take a little quick break, and I'll be right back. Um, so actually, I think if we make all these like I just feel like the space shouldn't have 0 width though. Like how are you supposed to draw it normally? There's like a problem that with this update font metrics. Well, there isn't. There kind of is. We just need to make sure that like the glyph is actually uploaded. So I don't know. Maybe just to be safe, we should shove a little flag in there that says uploaded. And if we come in here and the flag is not set to uploaded, then we should actually return this. So how are we checking? We're checking right here. don't really want the GPU code, the GPL, that part of the code to like reach into this glyph cache though. Um, hmm. Like right now, this is a little sketchy, but we'll leave it. Um, it's fine for now. So let us take the win on this one. I think. I think we need. Oh, we do need the is power of 2. Right. Okay. So I'm gonna actually also just open a table. Unless I have one on here. Uh, Let me see here. Source C DWM config.h emoji. Emoji is in local share emoji. I don't think is on this computer. No. Okay. So we need just some giant table that we can just download. Just cat. Can I just want to download like a list? Like these stupid I just don't like the Unicode charts are all like these stupid PDFs. You can't just copy paste out of them because I mean that makes sense because they want to be able to display it even if the user system doesn't have the font. But can I just ask ChatGPT to give me a table? Oops, I did not want to do that. Um, of course, it doesn't want to just run this. Which of these ranges has like enough random things in it? Okay, we'll just generate one. Yeah, I'm just gonna write a little t.c, not t.sc, t.c gonna copy paste this encode thing for now. Standard int. Oops, standard def. I don't really need that actually, but anyways, struct whatever, let's just do it this way. Let's copy my thingy here. Okay, so for well, yeah, we can just run this in the thingy. So f write standard out encoded.data one encoded.length gonna do some dumb thing here because I'm lazy. I don't know, 128. Count equals 0. Then outside this loop, we'll do that again. How did that end up outside of main? Sure, that didn't really do that. Okay, so wait, what's it called? Oh, my bad. So if we do a fun, what did we what how did that even? Huh? So sorry, GDB. Okay, PT. We're just outputting like total garbage, so that's why we need to like figure out um what is going on here. So in recycle cache, pop free glyph. What is that in hex? Uh, 3B, 3B. This shouldn't take like that long to print that many characters though. It's just a dot out to I mean, it is like pretty big file, I guess, but it will actually let us only print like 500. We don't need to print all of these right at the moment. 15, this should be 256, like maybe here somewhere, too. Okay, so we can't print any of this junk, it's not in the font, but, oh wait. I want this one. Okay. Yeah, that's the one we want. Why is that, like, giving valid characters in the old version? That's really weird. Let's do set sid. Let's open a little gf2 in the background. We're asserting this. We've got like some junk going on here. Wait, why are we... I think this is actually wrong. I don't think we're supposed to be asserting the hash slot here. I think that's wrong. What are we... We're not supposed to be asserting that in... Yeah, we don't want to assert the hash slot. We want to assert that, yeah, Yeah, sorry. That is totally stupid. Why did I do that? Um, though nothing should really be mapping to 0, but yeah, actually, let's look at what mapped to 0 here. Like, what's this code point? Is the code point 0? $65,000. So let's print the result. Compute glyph. Oh boy. Compute glyph hash 65,656. And it needs to take the GC. It's not void, dumb. Yeah, that gives you a 0. Yeah, so we need a better hash. Obviously, this hash is no good. Um, yeah. Okay. So have a look, see here. So the glyph cache length is like 512, so it's pretty small. And we want oh yeah, sorry, we can have the 0. Sorry. Yeah, we don't want to be you're right. You're right. We don't care about the hash slot being 0. We care about the this index should not be 0. Let's kill this. Move this over. Let's fix that quickly. Recycle LRU thing. Hash slot can be 0. Wait a minute. So this next with same hash could be 0 though. Yeah, I don't know what I'm even what am I even trying to check here? I think this should not be 0. Oh yeah, no, sorry. Yeah, we're trying to figure out which glyph is the first. Sorry, what are we doing here? Brain is completely fried. I think I was supposed to update something here that I didn't fix. I think that's what the problem is. It should be here. It shouldn't be this hash slot here. Yeah, this is what I wanted. Sorry. And this should be asserted that it's not 0. We're gonna walk through this table until we find the point where I still feel like this is weird, but let's just try this for a second. Okay, where is that breaking now? Probably for a different value, but um just tonight, Sentinel, blah blah blah. Okay, so we want to figure out which hash table slot is so we want to figure out the first entry that has the same hash as whatever this entry that we're just going to be recycling is. So we get this hash slot, we compute it, and then we figure out, okay, then we go there, we get this is the first entry index that has the same hash thing. And what should be happening here is that remove the least recently used element from the LRU chain. I think this is correct. So let me think. Get slot pointer. Next index. Get entry. Table plus index. For the next with the same. So this shouldn't really be returning a 0 because this last index needs to be in the table. If we're at this point. Just step through. Let's go back to this initialize glyph cache. And we're just going to walk through this again. So for all the glyphs in the glyph cache, we are going to grab it. We're going to link the next one to the previous one. Next with same hash be the next index. So it just walks down the chain when this table's invalid. Code point should be 0, next and previous should be 0'd. We're going to clear everything in the hash table. That's correct. Okay, that should be all fine. Then, when we come in here, we're going to do a get glyph entry index. So the result is 0. We compute this hash slot. We compute the entry index. So while there's an entry index, we're going to say, we're going to grab the glyph, the cached glyph, and if the code point that we're looking for is equal to that code point, we're going to store the result. We're going to store that index as the result. Otherwise, we're going to jump to the next thing in that glyph chain. And we're going to keep going until we get 0 or a result. Then, so if there's a result, if there is a result, we are going to use this thing. Yeah, this is going to always be the case, unless this was 0. So the first time through, this is always going to be false. But that's fine. So actually say let's go through. Well, so this is going to be right though. So we go get the previous one, get the next one in the chain. We set the previous to the next to be equal to the correct one here. So this is just this one. So yeah, we're just pulling out this one from the center of the chain here. Then we're saying we're going to grab the sentinel and we're going to grab the last next element. We're going to take the sentinel. So our element, our thing is now going to be now the next node, sorry, is going to be, so this sentinel, the first one is the most recently used. So that's going to be this result that we just computed. And then the last next, which was the last most recently used, its previous is going to be this one that we just pulled out. And then the previous for us, the one we just pulled out, is going to be 0. And the next for us is going to be whatever this last next index of this last next one. So this part is all good. So then it's going to be in this branch. So we're going to pop a free entry. And what we want to do when we pop the free entry is we want to get like the first entry that's free. So if, so let me just see here. The Sentinel starts out with like a next hash. So if it doesn't have a next hash, Sentinel is going to start out with that next hash, right? So always going to point to the first element on the first time through. So that would give us this result here, which is going to be the first slot. And we're going to store, we're going to grab that glyph. We're going to say that Sentinel to next with same hash is going to be that one. It's next with same hash. So like the first time through, that'll be like the number 2. Then we're going to set its next hash to 0. So there's not, because we haven't registered anything yet. So that's going to be correct. Let's make sure that what we do with that result's correct. So when we get that, we're going to adjust this glyph pointer thing to be the result. Then we're going to say that the next, really windy outside, that the next hash for this guy this actually does, this part I think doesn't make sense. I guess it's probably right. So next with same hash, we've got our hash slot. Whatever is stored there now. That's right, yeah. So whatever is stored there now is going to be the next, that's correct. And then we store this code point. I'm just going to reorganize this. And then we go back to the hash table and we say the first result for this hash slot is going to be the one we just computed. This part is correct. We're handling that part correct. Now, when we go in here and we get that there isn't a next hash next with same hash, it's got to the end. We have to go into this recycle cache. So we're gonna grab that Sentinel. There shouldn't be like a previous node on the Sentinel. There should be a previous node on the Sentinel. Should there be? That doesn't actually make sense. Where do we set Sentinel to previous? Oh, right. Yeah, so by the time we get here, the Sentinel has to have a previous node on it. Wait, no. If this is the only place where we set it, because we don't touch this Sentinel anywhere else. We shouldn't be anyways, besides in this initialize routine. Here. I feel like the Sentinels should be the last index in the table. Is that gonna work out? I think so. I mean, that's not the assertion we're hitting though, so I'm gonna like ignore that for now. Not sure. Not hitting that assertion, so let's just assume that's correct for now. Okay, so here's our last index. We come in here, we get the glyph pointer, or so we get the cached glyph for the last index. Then we get the previous one that was linked to this last index, so the one right before it. The previous one to the next one is going to be 0, so it's now the end of the chain. The sentinel to previous is now going to equal the last one's whatever it was pointing to as the last previous. So it's actually this index, the index that gave us this previous one. That's like all correct. Then we come in here, we compute the hash for this last index. So for the glyph at this last index, which then tells us the first index with the with that hash. This is going to chain it. So we then go in and say, okay, so if it was already just equal to the last index, we skip over it. Otherwise, we go into here and we say, we assert that we have an index that's not 0 because it cannot be 0. So the index definitely cannot be 0. Like there's no way the index can just be 0. I mean, like I guess it is, right? Like at the start. At the start. Get slot pointer. Yeah, I mean, this is exactly just what I'm doing besides. Okay, so like heavily modified from this though, but in any case, yeah, so this should all be fine. What we want to do is we want to get the entry. So we're going to get this entry of this next index. We're going to grab its next with same hash value. This looks fine to me. We still have something open here. Yeah, so what was like the last index? It was like 35. How do we get this how do we get this next with same hash to be 0? That doesn't make sense. It should never be. So where is that just getting set to 0? Right. So the last element in the table has a next with same hash of 0. Hash slot is 33, so the hash slot is 33. This next index came from the hash slot. Let's just check that. GC to hash table, hash slot. That can be 0. That's correct. Previous was 36. Next is 34. The Sentinel's next with same hash is 0. Isn't that like wrong? I think that is wrong. How is the Sentinel node ending up having a next with same hash of 0? Because that is not correct. I might have to stop soon as well, but we will see. Let's look at the stack quickly here. So render glyph. Right, set glyph doesn't really matter. Get glyph entry. Obviously we came in here and there was no thing that hit this slot, so in here it was our hash slot, 506. And at that point we had a 373, so we went to we had a code point of 65,813, which is not the code point that we just have here. So the next with same hash was 204. Then we went to 204. Is still not what we wanted. So the next with same hash for this one was 0. So we broke because that was 0. We then said, okay, there's no free glyphs. So we're gonna go into here. Right. Okay, that makes sense. And the Sentinel, which is 0, had an X with same hash of 0. Which is correct. Right, that's how we get into this recycle cache. So this chain is like internally going back to itself. So what's this sentinel to previous? It's 36, so there is like a value. Go to the wash. So we've got sentinel previous, last index. So then what we've got is oh, we've already stored it. Sorry, that's why this is already 36. This last index was actually the last index. So that would be, close some of this for now. 35 was the actual last index. So we modified that yet? No. Obviously that's 36. $66. Okay. So we computed this hash slot at 33. See, this is like a problem because if this hash slot, if what's stored there is a 0, we link ourselves to the sentinel, but we've already modified. I guess we've modified the sentinel, but we haven't modified the next with same hash. It's just that the sentinel could have a next with same hash of 0, which then means that so this is like correct. It's just like, how are we getting to this point? Let me think here. So this should, it has to be 0. It has to be 0 for us to just come in here. That makes sense. But then why does How do we get this hash to point to this, like this? Something has to be going wrong. It's like, here's the problem. If this is 0, right? Next index still does not equal last index. We go back in here, this is still 0, so it's like linked to itself. We just keep checking the same one over and over again, which obviously is going to break everything. So that means that somewhere else, like it can't be in here where this is going wrong. It has to be like here, I think, or here where we're like updating. Are we touching something else somewhere that we're not supposed to be touching? Index in the GPU where this should be uploaded. That's like correct. Validate LRU. Find glyph entry. Pop the pre-entry. So this is what we're doing here. So am I just forgetting to update something somewhere here? So here we should assert result. That is correct, because like this shouldn't be the sentinel node. At this point. Because if the result, we're not in here at this point yet. If the result was 0, then we'd clobber something here. PG to previous index is going to be equal to 0. That is correct. Sentinel to next should be the result. Last next to previous should be the result as well. So I am not sure I'm going to be able to find this without properly just stepping through and making sure that this code works. So rather than bore people with that, I think we will call it there for now. And I will do that later. So if I just change here. Okay. Does this still work without just printing random garbage? Probably. Yeah. So as long as we're like doing this, it's still all good and good to go. So thank you for watching. I will come back tomorrow. I don't know what I will be working on tomorrow. Maybe hooking up the font config stuff so that we can get proper full Unicode coverage. But maybe not. We'll see. Yeah. So I will probably just debug this a little bit more tonight off stream and correct it. I'm sure it's just like some really stupid thing I'm doing wrong. I just need to step through it to find it. Okay, so cool. Thank you for watching, and I will see you all next time. Bye.